Hello students, welcome to Modern Institute of Pharmaceutical Sciences Indore. Here I am Kritika Sharma and today we will discuss about sulfonamides. So first I explain what is sulfonamide. First one is history of the sulfonamide. So the first antibacterial agent effective against the pyogenic bacterial infection. Pyogenic bacterial is Streptococcus aureus. This bacteria is causes the pus formation into the skin. So prontosil ray is a first antibacterial agent. This is a dye and the dye is used to treat the experimental of the Streptococcus infection in a mice and was found highly effective and used to care the infant of the Streptophilococus. In 1937, the scientists have studied the prontosil was broken down in a body to release the sulfonilamide. Sulfonilamide is agent to active the antibacterial agent. After this, a large number of synthetic sulfonamide were produced. This is a bacteriostatic agent. Bacteriostatic, that means this agent is inhibit the growth of bacteria and extremely used the year of the come. However, use the sulfonamide become is limited. Its rapid emergency of the bacterial registration and availability of the safe and more effective drug. This is a sulfonilamide structure and the sulfonilamide is contained the para-aminobenzene ring. The N1 substitution is responsible for the solubility, potency and pH property and the N4 free amino N4 position of free amino group is required for the antibacterial activity. The sulfonilamide structure is similar to the PABA. PABA, that means the para-aminobutyric acid. This PABA is responsible for the nucleic acid synthesis in a bacteria. This is a classification of the sulfonamide. First is short acting. The D half of short acting is 4 to 8 hours. The example of the short acting is sulfadiazine, and the B is the intermediate acting is D half 8 to 12 hours. And the example of intermediate acting is sulfamethoxazole, and third C is long acting, the half life of 7 days, and the example of the long acting is sulfadoxine and sulfamethopyrazine. And the special purpose of sulfonamide derivatives is sulfacetamide, sodium, silver, sulfadiazine, sulfasalazine and mefenide. According to the route of administration, the sulfonamide derivatives is classified. First is orally absorbably, is short acting. The example of the short acting is sulfadiazine, sulfacetamide and sulfamethizole and sulfasoxazole. And the intermediate acting of sulfonamide derivatives is sulfamethoxazole and sulfamoxazole. And long acting is sulfadoxine and sulfamethopyrazine. Orally non-absorbable is sulfasalazine, osalazine and belasalazine. And the topical agent is silver, sulfadiazine, mefenide and sulfacetamide sodium. Then the mechanism of action of sulfonamide derivatives is broadly put, sulfonamide is inhibit the nucleic acid synthesis, and specifically sulfonamide inhibit the synthesis of the folate in a bacterial. This is a cycle of synthesis of nucleic acid. So first is pteridine and PABA is converted into the dihydrobutyric acid in a presence of the dihydrobutyric acid synthesis, folic acid synthesis, converted into the dihydrotoric acid, and the presence of the dihydrotoric acid in the presence of the glutamate is converted into the dihydrofolic acid. Dihydrofolic acid is converted into the tetrahydrofolic acid in the presence of the dihydrofolate reductase. Tetrahydrofolic acid is converted into the RNA DNA protein is for the precursor of nucleic acid synthesis. The tetrahydrofolic acid is also made folic acid in the presence of the dihydrofolate reductase in a human body. So basic folic acid is very essential for the growth of the bacteria, for the nucleic acid synthesis, and bacteria synthesis when the folic acid from the papa. So sulfonamide derivatives is enter the sequence of the papa, and is also decreases of the dihydroproteoric acid synthesis. So is mainly affected the nucleic acid cycle, so decrease the growth of the bacteria, and is also known as bacteriostatic in nature. Thank you.